In these videos, we're going to talk about methods for solving quadratic equations. So that would be having something of the form ax squared plus bx plus c equals 0 and finding all possible solutions for x that makes that work. In this video, we're going to look at two methods. We're going to look at the square root property and the zero product property. So the square root property is going to come up when we do not have a bx term. If we just have ax squared plus c equals 0, if those are the terms we're working with, we can use the square root property. What the square root property says is that if we have our variable squared and it is equaling some value, let's call that m, what we can do is to solve for x is take the square root of both sides. And when we do that, the square root and the square cancel out, so we'll just have x equals, and then we end up with plus or minus the square root of m. Now, it's a very common mistake to leave off the plus or minus, but it's very important to have it. So as an example, let's say we have x squared equals 4. And we take the square root of both sides, and we end up with x equals plus or minus 2, which is the square root of 4. Why we get both of those is because positive 2 squared is equal to, in parentheses, negative 2 squared equals positive 4. So we end up with two possible solutions here, and in solving for x, it's the idea that we're looking for all possible solutions. So when we use a square root property, we must have plus or minus. The only time we won't is word problems. Word problems will probably be looking for the positive answer only, but all other cases, we're looking at plus or minus. Another property that we're going to be using is the zero product property. This is going to come from if we factor. So say we take our ax squared plus bx plus c and we factor it so that we have these factors multiplying equals 0. Well, a special property occurs when two things are multiplying or even more things are multiplying to equal 0. So if we have a times b equals 0, well, for something to multiply to 0, one of those has to be equal to 0. So what we can do is end up splitting this up and say, okay, a has to equal 0, or b has to equal 0, or both. But what this will let us do is split up where we have our two factors. We could solve for where one equals 0 and where the other one equals 0. So let's try these out and see these two properties at work. So this first one, I see I have a trinomial there. So I'm going to factor. First thing I start with is greatest common factor, which there is a 3 I could factor out, which will make things simpler. And I'm going to keep factoring. And let's see, multiplying to negative 6, adding up to positive 1. So that'll be an x plus 3. And an x minus 2. Okay, and something we could have done actually at the beginning. Sorry, let's go on here and then I'll go back to what we could have done at the beginning. Okay, so at this point I could start splitting up the equation. So we have that x plus 3 should be equaling 0, or x minus 2 should be equaling 0. I don't need to worry about that 3 out front because x isn't involved there. Okay, subtract 3 from both sides, so I'm getting x equals negative 3, and adding 2 to both sides, x equals positive 2. So I end up with two possible solutions right there. Some important notes. We have to have 0 on one side of the equation. That's what makes it the zero product property. So to do that splitting up of the equations, we can only do that with 0. If it's any other value, what we need to do is take steps to move it over to the other side of the equation. And what I was going to say is at the beginning, we could have just divided out 3 instead of factoring out. So I could have gone divided by 3, and then as long as I do it to the other side, which that would just stay 0, we could have just had that and not worried about the extra 3. So if you have a greatest common factor that's just a numerical value, you could divide it out instead of factoring out. But as you can see, it accomplishes the same thing. Okay. This is a case where we do not have the bx term. So with this, I'm looking to use the square root method. There is a way of doing this with factoring. And in fact, maybe I'll split this in half so we can see it both ways. But let's take this y squared minus 25 equals 0. And what I want to do is get that y squared alone on one side of the equation. So I'm going to add 25 to both sides. And then that is the perfect setup for taking the square root of both sides. So I'm going to have y equals, can't forget my plus or minus, super duper important, square root of 25 is 5. So you could leave it just like that, or if you want to list the answers, it's y is a positive 5 or y is a negative 5. That works as well, doing the same thing. Okay, another way we could have gone with this is this could be factored as a difference of squares. This isn't always the case with these, but what we could have done is factor this, and we would have had y plus 5 times y minus 5. So we'd have a y plus 5 is equal to 0, or y minus 5 is equal to 0. And solving, we would get our y equals a negative 5, y equals a positive 5, and we get to that same spot. Okay, a few more examples here. So I have x squared equals 8 times an x minus 2. And maybe you're thinking, ooh, I could just take the square root of both sides and be done. But we have x stuck in there, and we don't want to get that stuck underneath the square root. So that's not going to work for us. Instead, what we want to do is let's simplify the right-hand side of the equation. So I'm going to distribute the 8 in. So I have x squared equals 8 times x minus 16. And then I need 0 on one side of the equation, so I'm going to subtract 8x from both sides and add 16 to both sides. So that moves everything onto the left-hand side of the equation, and then I'll just have 0 left on the right-hand side. And from there, I'm going to try to factor. So multiplying to 16, adding up to negative 8, that will be an x minus 4, x minus 4. And with this, we're going to end up with the same equation twice. And what we could have even done is notice that was a perfect square trinomial and written it as x minus 4 squared equals 0. All we're going to need to solve once is just x minus 4 is equal to 0, add 4 to both sides, and we get one solution for this, which can absolutely happen. With solving quadratic equations, you can end up with 2 solutions, 1 solution, or even no solutions. So those are the cases we're looking out for. Okay, with this one, it looks pretty much set up, but what I don't like is that negative out front. So what I'm going to do is I'm going to divide everything by a negative 1, just so that I get that x squared positive, because that helps our setup for factoring. So that'll be now a minus 11x plus 18 equals 0. And we'll factor, so multiplying to positive 18, adding up to a negative 11, I'm thinking 2 and 9. So x minus 2, x minus 9. So x minus 2 is going to equal 0, or x minus 9 is going to equal 0. So x is a positive 2, and x is a positive 9. And there's our solutions. Okay, 2 more examples here. With this one, we don't have 0 on one side, so we need to take the extra step to make sure that 0 is on one side. So to do that, I'm going to subtract 30 from both sides of the equation. So we have 2y squared minus y minus 15 equals 0. And we could do some guess and check here of what would work, but let's go ahead and get a review of that AC method. So I'm going to do 2 times the negative 15, so I'm looking at factors of negative 30, and I'm looking for the ones that add up to a negative 1. I'm thinking of 5 and 6, so either a 5 and a negative 6, or a negative 5 and a positive 6, and we're going to want the 5 and negative 6. So with that, I'm going to split up that middle term. So I'm going to rewrite this as 2y squared plus 5y minus 6y minus 15 equals 0. And then we go for a grouping method. So we have a common factor of y, which will leave us with a 2y plus 5. Common factor of negative 3, so a positive 2y plus 5. So we have our common factor of 2y plus 5. And the leftovers of y minus 3. And I'm running out of room because I wrote so largely, but I need to do the solving process now. So 2y plus 5 is equal to 0. Subtract 5 from both sides. Divide by 2, and we're getting y equals negative 5 divided by 2. And then we also have y minus 3 equals 0. Add 3 to both sides. And y is a positive 3 for our two solutions. Okay, another scenario here. So this is where we don't have our bx term. So what I could do is move things so that I am isolating t squared alone on one side of the equation. So I'm going to add 4 to both sides and divide by 9. Some students want to try to take the square root at this point, but we want t squared completely alone. So I need to use that step of dividing both sides by 9, so then we have t squared equals 4 divided by 9. Then I can take the square root nicely, and we'll have t equals, don't forget the plus or minus, and then that square root will be 2/3. And we could leave it like that, or if you want to split it up as positive 2/3, negative 2/3, that works as well. So there is our square root property and zero product property so that we can solve either through factoring or square root method.